Another example, let's say for example, I have 3 divided by 2. So our expected result should be 1.667 or 1.67. But for programming, if you divide a whole number to a whole number, the resulting value is just a whole number, not with fractional components or decimal numbers. So in this case, the value here is just 1, or the resulting value is just 1. While for the remainder, if that is 3 modulo 2, again, we get the remainder when we divide 3 and 2, and that is also 1. So to make it easier and for you to find out how are we going to get the quotient and how we are getting the remainder, we use the standard or the normal divisions that we follow during our elementary and high school days. When we say 3 divided by 2, this is actually the format. 3 divided by 2. So in getting the quotient, so this is 1, 1 times 2, 2, 3 minus 2 is 1. This is the quotient, and this is the remainder. Okay, please take note of that. Okay, so another example is, for example, I have 3 divided by 2.0 or 2.00. So this time, it's no longer 1, but instead with 1.667. Or the other way around, 3.0 divided by 2, that's still 1.667. Or both have a fractional component, 3.0 divided by 2.0 is equal to 1.667. But if the numerator and the denominator is just an integer or a whole number, the resulting value should be or must be a whole number. So take note of that when we are dealing with the quotient. Okay. Last, what if I have 2 divided by 3? So the answer here is 0. Okay, but if it's 2 divided by 3.0, it's 0 point with the value in decimal. Now, let's go back to the remainder. What if our remainder is 3 modulo 2.0? Okay, so this is invalid. So take note that for the remainder, it must be integer on the left operand and integer as well on the right operand. We cannot divide or we cannot get the remainder if there is a decimal or fractional component within the modulus division. Please take note of that. Another thing is, for example, I have 2 modulo 3. So what's the answer? Shortcut is, if the left operand or the numerator is lower than the denominator or the right operand, just copy the left operand and the final answer or the result is 2. Regardless of how big is the value. For example, 20 modulo 114, so the answer is still 20. So let's have the examples for arithmetic operators. So again, don't forget to follow the hierarchy of priority of operators. So if you encounter a parenthesis, expressions in a parenthesis, we need to process it first before the expressions outside the parentheses. So this is 10 plus 4 times 18. So we all know that multiplication is higher than addition. So we need to multiply first 4 to 8 and then add the resulting value of 4 times 8 to 10. So that's 42. Next, modulus division and minus. So again, priority of operator should be modulus division, then followed by minus. So we need to get the remainder first of 50 modulus division of 6. So again, so how are we going to do that? So 50 divided by 6. So this is 8. And this is 48. This is 2. So the remainder is 2. Okay, then subtract 2 to 5. So that's negative 3. Then another example, 20 divided by 4 times 9. So all are the same hierarchy or level of priority. So in that case, we need to follow the associativity of processing it from left to right. So it should be 20 divided by 4 first, then 5. So the resulting value 5 would be multiplied to 9, and that's 45. Let's have another example. So, for example, we have 2 times 3 plus 4 divided by 2 minus parenthesis 7 plus 8, then modulo division of 5. So in this case, we need to process first the expressions within the parentheses. So I'm going to use 2 times 3 plus 4 divided by 2 minus 8 plus 7 plus 8 is 15 modulus division of 5. Okay, so we process first the expressions inside the parentheses. Then we have multiplication plus division minus and modulus division. So here, multiplication, division, and modulus division are in the same level, so we need to prioritize them. Then since they are in the same level of hierarchy, so we need again to follow the associativity of processing it from left to right. So this becomes 2 times 3, 6. 4 divided by 2 is 2. 15 modulo 5 is 0. Okay? So again, how can I get 0 from the remainder? So again, 5 divided by 15, this is 3. 3 times 15 is 3 times 5 is 15. 15 minus 15 is 0. So again, this is the quotient and this is the remainder. So next, following by addition and subtraction. So again, same level of priority. So we need to follow the associativity rule of processing it from left to right. So I need to add first 6 to 2. So this becomes 8. Then minus it with 0. So that becomes 8. So the final answer is 8. For string expressions, we only use the plus sign. Plus sign is not addition, but rather this is concatenation. Concatenation means combining two strings together to get the resulting value. So let's say for example, I have a string 3, concatenated it with string 4. So the answer is string 3, 4. Then another example is I have a string glow, concatenate it with a string ren, so the resulting value is string glorin. So these are the following examples of incorrect usage of the plus or concatenate operator. So for example, you have string 3 plus numeric 4, so you cannot process a string and concatenate it to numeric. It should be string plus a string as well. So these two examples are incorrect because from the first example, the right operand is 4 and that is numeric, and the other one is on the left operand, that is 100. So you can actually concatenate the values or join the values of a numeric 1 to a string 1. Another type of expressions that we're going to use is the relational or comparison operators or expressions. So please follow the symbols. Greater than, less than, greater than or equal to, less than or equal to, not equal to, and is equal to. So you do not use the less than or greater than or equal to same as the format in mathematics. You should use this type of symbol.